When German Luftwaffe reconnaissance pilots flew over the Normandy coastline in the spring of 1944, they photographed empty fields and quiet farmland. But when they returned just 24 hours later, they found themselves staring at fully operational airfields, complete with runways, fuel depots, and aircraft ready to launch sorties deep into occupied France. The impossible had become reality, and the men responsible were Canadian engineers who'd perfected a system so revolutionary that it changed the entire calculus of air warfare in the European theatre. What the Germans didn't know, what they couldn't have anticipated even with their vaunted intelligence services, was that Canada had spent years developing rapid airfield construction techniques that could transform bare earth into a functional military airstrip in less time than it took to fight a single battle. This story begins not with the dramatic D-Day landings that everyone remembers, but in the frozen expanses of Canada's north, where engineers faced challenges that would prepare them for feats the German High Command considered logistically impossible. The Royal Canadian Engineers, known as the RCE, had been grappling with a uniquely Canadian problem long before World War II began. How do you build infrastructure in a country where vast distances, extreme weather and difficult terrain make conventional construction methods impractical? The pre-war Canadian North, with its permafrost, muskeg swamps and remote locations, had forced engineers to develop innovative techniques for rapid construction that could be completed during brief summer months before winter shut down all work. These skills, honed in peacetime conditions that were nevertheless extraordinarily challenging, would prove invaluable when war came, and the demand for military infrastructure exploded. Historical records from the Department of National Defence show that Canadian engineers had already experimented with prefabricated materials, modular design and construction methods that prioritize speed over permanence, creating a doctrine of rapid deployment that other nations had largely ignored in favor of building more elaborate, time-consuming facilities. When Canada entered World War II in September 1939, the RCE found itself facing demands that seemed overwhelming. The British Commonwealth Air Training Plan, which would eventually train over 130,000 aircrew from across the Commonwealth, required dozens of new airfields to be constructed across Canada within impossibly tight timelines. The first major test came in 1940 when the Canadian government committed to building training airfields at locations from Nova Scotia to British Columbia, facilities that needed to be operational within months rather than the years that peacetime construction would have allowed. Engineers like Major John Russell, whose detailed reports are preserved in Library and Archives Canada, described the initial panic when orders came down to build a complete airfield near Moncton, New Brunswick, in just 90 days. Russell's team faced forested land that needed to be cleared, drainage issues from local water tables, and the challenge of sourcing materials during wartime when everything was in short supply and competition for resources was fierce. What emerged from this pressure cooker environment was a systematic approach to airfield construction that broke the process down into components that could be executed simultaneously rather than sequentially. Traditional construction methods required completing each phase before moving to the next, but Canadian engineers developed techniques where surveying, clearing, grading and surfacing could all happen in overlapping timeframes, with different teams working on different sections of the same project. Documented accounts from construction battalions show that this required unprecedented levels of coordination and planning, with engineers creating detailed schedules that mapped every piece of equipment, every work crew, and every shipment of materials to specific tasks at specific times. When one team finished clearing trees from a section of land, grading equipment was already waiting to move in, and behind them came the surfacing crews with loads of crushed stone or the new experimental materials that Canadian engineers were testing. The development of portable steel matting, known as Marston mat or pierced steel planking, revolutionized rapid airfield construction, though the Canadian contribution to refining and deploying this technology is often overlooked in histories that focus on American development of the material. The basic concept was simple: interlocking steel plates with holes to reduce weight could be laid directly on graded earth to create a surface strong enough to support aircraft landings and takeoffs. But the execution was anything but simple, and Canadian engineers working at experimental stations in Ontario conducted extensive testing to determine optimal laying patterns, drainage requirements, and soil preparation techniques. Reports from these testing facilities, preserved in military archives, show that engineers discovered that the matting worked far better when laid on specific types of aggregate base, and that drainage was absolutely critical because water accumulation under the matting could cause it to shift and buckle under aircraft weight. The first real-world test of rapid Canadian airfield construction came not in Europe, but in the Pacific and North Atlantic theatres. When Japan invaded the Aleutian Islands in 1942, Canadian engineers were dispatched as part of the Allied response to build airfields in some of the most hostile terrain imaginable. The Aleutians presented every possible challenge: volcanic rock that was difficult to excavate, constant wind that made construction dangerous, fog that limited visibility for weeks at a time, and supply lines that stretched across thousands of miles of ocean. Lieutenant Colonel William Howe, whose memoir was published in 1968 after he'd retired from the military, described landing on Adak Island in September 1942 with orders to build a bomber base capable of supporting B-24 Liberators within 30 days. Howe's account details the organized chaos of round-the-clock construction, with work crews operating in shifts, bulldozers grinding through volcanic rock, and supply ships arriving with pre-cut lumber and steel matting that had to be unloaded in small boats because the island lacked deep-water dock facilities. The techniques refined in the Aleutians and in Canada's north became doctrine by 1943, codified in training manuals that were distributed throughout the RCE and shared with Allied engineering units. These manuals, which can still be found in military history collections, read like recipes for airfield construction, breaking down the process into standardized steps with estimated timeframes for each phase. A typical rapid airfield construction project required reconnaissance to identify suitable terrain, surveying to establish grades and drainage patterns, clearing of vegetation and obstacles, rough grading to create the basic runway shape, installation of drainage systems to prevent water accumulation, fine grading to achieve precise runway specifications, surfacing with either crushed stone or steel matting, and finally, installation of auxiliary facilities like fuel dumps and maintenance areas. What made the Canadian approach revolutionary was the compression of these steps into overlapping phases that could be completed in days rather than months. The planning for D-Day included extensive analysis of how Allied forces would maintain air superiority once they'd established a beachhead in Normandy. Traditional doctrine assumed that captured German airfields would be repaired and used, but intelligence reports suggested that German forces would demolish their airfields thoroughly before retreating, and captured facilities would require extensive reconstruction before becoming operational. Canadian planners proposed an alternative: forget about capturing German airfields, and instead build new ones so quickly that Allied aircraft could be operating from French soil within hours of the beaches being secured. This proposal was initially met with skepticism from some Allied commanders who considered it logistically impossible, but detailed presentations by Canadian engineering officers, backed by documentation from airfields they'd already built in record time, convinced planners to incorporate rapid airfield construction into the invasion plans. The 1st Canadian Airfield Construction Wing, specifically formed for the Normandy invasion, consisted of multiple squadrons of engineers, each trained to execute specific phases of airfield construction with mechanical precision. Personnel files show that these units underwent intensive training in southern England during the months before D-Day, practicing their procedures on British farmland with stopwatches running and officers noting every inefficiency. They practiced laying steel matting in the dark, grading runways while under simulated artillery fire, and coordinating supply deliveries when vehicles were stuck in mud or damaged by hypothetical enemy action. This training paid off when the actual invasion came, and conditions were far worse than anything they'd simulated. The first Canadian-built airfield in Normandy began construction on June 8, 1944, just 2 days after the initial D-Day landings. The site, designated B2 and located near Basenville, was still within range of German artillery when the first engineering teams arrived with their bulldozers and graders. Sergeant James MacDonald, whose diary was later donated to the Canadian War Museum, described the surreal experience of operating heavy equipment while shells exploded close enough to shower the work crews with dirt. The engineers worked in shifts around the clock, with some men operating equipment, others unloading supplies from trucks that arrived in convoys from the beaches, and still others beginning to lay steel matting, even as other sections of the runway were still being graded. German reconnaissance aircraft spotted the construction activity and attempted to bomb the site, but Allied fighters provided air cover and the work continued with minimal interruption. Within 72 hours of breaking ground, the airfield at Basenville was operational. Allied fighters began using it on June 10th, less than a week after D-Day, flying sorties that supported ground troops advancing inland from the beaches. German commanders were stunned by intelligence reports of aircraft operating from locations that their maps showed as farmland, and Luftwaffe pilots, who'd grown accustomed to Allied aircraft operating from bases in England, suddenly found themselves facing fighters that could respond more quickly because they were based just miles from the front lines. The psychological impact on German forces was significant. The speed of Allied airfield construction suggested a level of logistical capability and planning that made resistance seem even more futile. The Canadian engineers didn't stop with one airfield. Over the following weeks, multiple advanced landing grounds were constructed across Normandy as Allied forces pushed inland. Each airfield followed the same pattern: rapid site selection based on terrain analysis, immediate commencement of clearing and grading, installation of drainage and steel matting, and operational status achieved in 3 to 5 days, depending on conditions. Historical records from the Allied Expeditionary Air Force show that by the end of June 1944, Canadian engineers had constructed or expanded 6 separate airfields in Normandy, each capable of handling fighter and light bomber operations. These facilities were basic by peacetime standards, lacking proper hangars, extensive maintenance facilities, or comfortable accommodations for personnel, but they served their purpose perfectly, putting Allied air power as close to the front lines as possible. These instant airfields let Allied planes stay close to the front, providing relentless air support and returning to base in minutes. The constant pressure from the skies shattered German morale and supply lines. The secret wasn't new technology. It was a philosophy forged in the Canadian North, where survival meant building fast or not at all. To understand these ghost airfields, we must look back to a time before war, when Canadian engineers learned to outpace even the brutal winter. Their skills, honed in isolation, would become one of Canada's greatest contributions to Allied victory. The Germans never solved the puzzle of these vanishing airfields. The answer lay not in Europe, but in the frozen forests and swamps of Canada. There, a generation of engineers learned to build with a speed and pragmatism the world had never seen. Their methods would soon change the course of the war. The story of Normandy's ghost airfields begins far from the battlefield. It starts in the wild, unforgiving north, where time was always running out, and it ends with Allied air power dominating the skies over France. Before war, Canadian engineers faced a different enemy, the land itself. The north was vast, rugged, and unforgiving. Building anything was a race against the short summer. Delay meant failure, the ground froze, and work stopped for months. This pressure forced innovation. Engineers learned to work fast, improvise, and use whatever was at hand. They cleared forests, blasted rock, and built on swampy muskeg, all before the first snowfall. There was no time for slow, step-by-step construction. Projects overlapped. Land cleared while foundations were laid, materials prepped off-site. The result was a uniquely Canadian approach, rugged, functional, and fast. They weren't building monuments, they were building lifelines, and speed was survival. These lessons in logistics and urgency shaped a generation of builders. Their methods would soon be tested on a scale no one could imagine. The blueprint for rapid military construction was born in the wilds of Canada. Soon it would